Hello, fellow AEC 6211 classmates. This video is being done without an audience, and so I'm going to kind of pose questions to a basically empty room right now, and I'm also sometimes going to use those periods of silence and give some suggestions of what you should do with a classroom full of people. So I'm going to kind of go back and forth, so hopefully it doesn't throw you off too much. Okay, so today we're going to be talking a little bit more about matter here in our science class. We learned last week that matter is all kinds of things, so I'm going to give you some examples. Is this pair of sunglasses matter? Okay, yes. How about this pencil? Does this also matter? Yes, also matter. So matter is basically everything around us. So we know that we interact with things all the time, and so it's kind of important that we understand matter, and also we need to understand its physical properties because that allows us to manipulate it and to use it for our benefit. And so does anyone remember the phases of matter that we talked about last week? Okay, so we've got liquid. Yep, that's definitely one of the phases. Anybody else? Okay, solids, yes. And yes, gas would be the last one. So that is the three phases of matter, and they can exist in those, and we've got some examples here that we're going to be using today. So we've got like sand, that would be a solid. We've also got liquid water, and then just a bag of air. So we've got gas here. And so as we were talking about, and there was a couple different things that we needed to remember about matter, 2 rules. Does anyone remember what the 2 rules were? Okay, yes, matter takes up space and it has mass. Okay, so those are the 2 things we need to remember. And we're going to learn a little bit more and experiment a little bit more to understand what we're seeing so that we can put together the pieces so it makes more sense to us. Like I was saying before, everything around us is made of matter. The air that we breathe, the table that we have sitting in front of us, the shoes that we wear, the car that we drive, everything has matter. And it can be in those 3 phases that we talked about, and then it has to have mass, and it also has to take up space. And so as you can see in the little diagram here, we've got water in its 3 different phases. So we're going to do 3 different tests today that are going to give us some data, and it's going to allow us to better understand the different phases of matter. And so what we're first going to do is we're going to think about putting sound through matter. And so what that is going to allow us to do is kind of understand the arrangement of all of those little atoms that make up that matter. And so on your lab benches, you each have a bag of sand, which is going to be our solid, bag of water, and a bag of air. And so each person grab one of the bags, and then there's also a coin on the table. And so someone's going to have to be the coin tapper too. So basically what you're going to do is each person in the group, and with the sand it's going to be a little bit difficult, but kind of just like mound it up, and then you're going to put your ear to it. And you're going to do the same thing with the air and the same thing with the water. So each person in the group is going to grab one of the phases and stick your ear to it, and while doing that, someone's going to tap with a coin. So you're just going to put your ear to it. Okay. And then as you're doing this, talk with your group about what you're hearing. And then you're going to go ahead and move the different phases of matter around the group so everybody can listen and try the tapping. And I'm going to give you about 2 to 3 minutes to do this, but everyone in your groups go ahead and just start doing this, and then we'll discuss after we've finished about what you guys came up with in your groups, and we'll go ahead and add to the board of some data that we've got. So during this time, you would be, as an instructor, walking around, kind of listening in on the different lab groups, making sure that they're following directions, but also moving along through this process. Offer help if you can, if you hear that there's something that may be misunderstood or something that's keeping them from moving forward with this little project. And in the meantime, you would want to go ahead and write up this board. And so I did this ahead of time, but you could put this up while they're doing this part of the project, because these are things that obviously I just asked them about in the beginning, and you don't want to have them sitting right on the board. But I went ahead and did it ahead of time. And so during this time, just make sure that they're working on the different phases. And so I would regroup them at the end and just ask them, you know, what did you guys come up with? And so right now, we're going to talk about what happened with the sand. Does anyone want to tell me what happened with the sand? So it was kind of muffled. Okay, so it was hard to hear through. Okay, what about the liquid? Okay, so the liquid was kind of, you could hear a little bit of stuff. How about the air? Did anyone have any kind of idea how the air sounded? Okay, so it was clear. You could definitely hear the sound through it. Okay, and so liquid was kind of somewhere in between. We'll say muffled. Okay, and so that kind of gives us an idea of how those atoms are arranged in the batter. If you think about gas and how that was a clear sound, what else do you think of that has like a clear sound that you can hear straight across? Okay, so like a room or a hallway, something like that. Okay, so very wide spaces. And that's something that we know about gas. It's something that doesn't, it takes up the volume of the container that it's placed in. And so it can move into larger spaces, and the molecules are a lot farther apart. And so with liquid and solid, because they were muffled, you can tell that those atoms are pretty tight up next to each other, and they're kind of keeping the movement of sound from going through it. And so I wanted to show you guys a little website which shows us in pretty good detail. So as I was saying a second ago, we've got what a solid would look like in microscopic form. And so all of the little atoms are right next to each other, very tightly placed together, and they're not moving very much. And on the other hand, we've got liquid. And so we know that these are very close to each other because they're not like gas where they're very far apart, but they're moving. And so they can kind of move and flow around each other. And here's what we would see with a gas. And you see you've only got a couple atoms coming across here and then. And so this kind of shows us that there's a lot of space between those atoms. And the atoms are kind of bouncing around freely through the air or through their space, their volume. And they're able to bounce around and take up a larger space. And so as you add sound to that, you're bouncing these atoms. And so having this much space between them allowed the sound to come right through, whereas the solid and the liquid phase stopped the sound from coming through. Okay, and so we're going to move on to the second test. And this is where we're going to take solid ice and we're going to change it into a liquid. And so, you've seen this by just leaving ice in a cup out on a counter. And so what we're going to do is each of you at your tables has 2 500 milliliter beakers. What I want you to do is take maybe 3 ice cubes and place them in each of the containers. And then we're going to place one of these on top of the already warm hot plate. And so that's just going to sit on the edge there. And then one of the lab members is going to pull out a timer and set the timer for 3 minutes. And so we're going to allow 3 minutes to go by, and then we're going to discuss the differences between the one that got left on the table and the one that had heat applied to it. And so what I want you to discuss with your group through these 3 minutes is just how you think the heat is being used by the ice. And so what is happening with the heat and the solid that's creating this liquid? Just kind of start thinking and bouncing some ideas around, and we'll talk about it as soon as the 3 minutes are up. So again, during this time, you're going to want to walk around your groups and make sure that they're able to proceed forward and that they're kind of making dynamic conversation. You could interject with questions and pose some stochastic questions and get them kind of motivated and thinking. And after 3 minutes, we are going to discuss heat energy. And so I would like to ask the questions to the class and put them again on this little data board. And so just to the class, what did you guys think was happening between that ice to the water phase? Okay, so we have heat that's being applied to ice, and that heat energy is being absorbed by the ice. Okay, and as you can see, after the 3 minutes, you're gonna have liquid water at the bottom. And so we know that it's gone through a physical change. And so that heat energy is what created the physical change. Okay, so we'll say heat made the solid go to a liquid. Okay, so for our next test, we're going to take the liquid water, which has been heating up on your hot plate before you got here, and we're going to create steam. And so that is going to be taking the liquid to a gas form. And so right now you have your hot plate set at about 350. What I want you to do is go ahead and just crank them all the way up. And we're going to, again, set our timers for 3 minutes. And while we're doing this, I want you guys to talk about the heat energy and how those atoms are reacting to the heat energy that's being put into the system and what's happening between that liquid to gas phase. And so again, 3 more minutes and allow them to discuss with their group about what they assume is going on, which is, again, the heat energy is creating that physical change. And so after 3 minutes has gone up and everybody's kind of quieted down in their groups, I would just ask them to join again so that we could talk about the data table. And so I would ask them again, what do you think is going on between the water that's creating a gas? And so again, we're going to get the answer through either kind of probing them or giving them clues to get that heat was what made the liquid turn to gas. Okay. So, and this takes us to the phase change diagram. And this is a very kind of simple way of showing, basically this is what water does, but it's true of most elements. And so we would start out here with this ice as a solid. And as we know, all the atoms are very closely aligned and they're very tightly together. And so as we warm this solid, we end up getting melting, which takes us to a liquid form. And then in the liquid form, we've got these molecules and atoms that are kind of sitting around each other, flowing around next to each other. And as we add heat energy again, we get to evaporation, and then we've arrived at a gas. And as we continue to heat the gas, it can turn into other things. But I wanted you to also note that on top of this, with the blue text here, as you go reverse ways in the physical changes, so when you go from a gas to a liquid, that is condensation. And so that's the same thing that happens when you have like a cold glass of iced tea and you're sitting outside on a warm summer day. That cold glass next to warm air is going to allow for water vapor from the glass or from the air to stick onto the side of the glass. And so you're kind of collecting or condensing water. And again, that's taking heat away from the physical properties of those. So as you remove heat, as you add like ice basically to it, or add a lower temperature to it, it's going to create the condensation. And again, down here, when we change a liquid to a solid, as you know, by just sticking things in the freezer, that's the freezing point. And so that makes, again, you're taking the heat out of the situation and you're changing the liquid to the solid. So heat is being removed. And so it goes up this way with heat being added, and then as you take heat away, it comes down the other way. Okay. So today we learned a little bit more about matter, something that we followed up on from last week. And we wanted to talk about what are the 2 main rules of matter. Okay, it has mass and it takes up space. Great. Also, what are the different phases of matter that we just learned about in detail? We've got solid, a liquid, and a gas. Perfect. Okay, we also learned about the arrangement of the atoms and how close together they are in what? Solids. Okay, perfect. And then you're going to kind of ease them through the rest of them. And then remind them again that heat energy is what is applied that makes these physical changes move upward through that diagram that I showed before. And again, matter is very important to us as human beings because we use it every single day. It's the clothes we wear, it's the food we eat, and it's the water we drink that keeps us hydrated. So matter is really important in our everyday lives, and we're able to manipulate things by knowing how these physical properties of the elements. Okay.